So here everyone, in this video what we're going to do is we are going to code a very basic smart contract about a DAO, right? So what basically DAO is, it's a type of organization that is going to govern or operate based on some sort of rules that are being encoded in your smart contract. Now, unlike traditional centralized governing structure, DAO is decentralized, and there are members who have got some sort of tokens, which make them and give them the voting rights for the organization. Now, so since they are decentralized, you don't have any central authority. So there's more transparency and more trust, in the process of the decision making, and they can be a reduction in the risk of corruption and manipulation. Okay. So DAO basically works on the basis of ERC 4337. It provides you with a type and structure for creation and management of a decentralized autonomous organization. It also gives you the structure for how the proposals are going to be made, how the decisions are going to be made, and so let's just simply deep dive into the coding part of it, right, without wasting any sort of time. So what we need is so let's just check it out, like what are some of the variables and what are some of the important functions that we need to know beforehand, before creating it, right? So let's first check out the functions. Those are, first of all, we need a way to add the members, right? Adding the members. Cool. Then we need a way to remove the members. Cool. Then we need a way to create proposals. Finally we'll vote it, right? And at the end we can have to execute the proposal, right? Now let's see more into it. So we will need a way where we can store the details about the proposal, right? What can be the details around the proposal? Those can be the description, those can be the vote count, those can be is it executed or not, right? That's a boolean value basically. Okay, so we need a way for proposal to be there where we are gonna description. We'll have the description, we will have the vote count, we will have is it executed or not. Cool. Let me just remove it out. Then we need a way for members, right? Who all are actually the members. So it will basically store addresses and member since, right? And one more thing we can add is how much token balance he or she or they have got, right? So we want the address to be stored. Then we want the time, like since he is there. Then we need token balance. Cool. Right. Let's get into it and start to code it out. Right, as soon as possible. Okay. So first of all, thing is pragma solidity. Um, let's say it goes with 0.8.0. Cool. I hope it will work fine. Let's say contract DAO. Okay, we talked about having some sort of very important items. Like, okay, let's create the functions first, and accordingly we are gonna create the variables and everything. So we are gonna have a function for adding a member. For adding a member, it will take it will take address value, address underscore member. Cool. It will going to be a public. Cool. So this is going to be our function. Another way is going to be function remove member. It will take address type, again a member, because the one whom you want to remove from it, public. Alright. Okay. I don't know why it's coming like this. I don't want to have it, but yeah. Anyways, Okay, then we will have creating a proposal, right? And the proposal is so what we want from the user, right? We just want to have a description from the user. This vote count and execution, true or false value will be allotted to it when the smart contract will work, right? When the people will vote, when the results are being shown, right? So what we want from the user is function. uh, it was for creating a proposal uh, string memory description. Cool. All of this, let's give it public. There we go. Right. Then we were going to have a function for vote. So vote, I'll let you know what we want from the user, because there are two things, right? We will map each and every proposal with an ID, right? And also the amount of token that you need to stake while making a vote, or while casting the vote for certain proposal. We'll again keep it a public, right? Cool. Okay, so as I said, we will give it a proposal ID. So let us just proposal proposal ID. I'm bad with spellings, not a big deal, but anyways, let's see. Token amount. I just I just kind of get confused, right? Done. And the last one is going to be function execute proposal. Again, the way we ask for proposal ID during the vote. For executing it, again we will need the proposal ID, right? Proposal ID. Cool. Again, we are gonna keep it public. Done. So these are all the functions that we are gonna create. Right. Just functions. Cool. Done. Okay, now we're done with it. So now let's just define our structures and our variables and each and everything that we need for it. Cool. So first of all, we need to have a struct, a proposal. Cool. So first of all, we talked about description. Okay, then you went vote count bool executed. Cool. Right. Yeah, it's all perfect. Struct. Now one for member. So it's gonna have the member address, then it's gonna have member sense, and then it's gonna have the token balance. Now address, member address, event member sense, token balance. Cool. We're done with it. Now we want some sort of more things, like we need to have an array which will store basically all the members, those are a part of this DAO. Then we need to have a mapping for information related to the members, like we are gonna map those addresses with this member struct. Again, we will have a mapping for the vote, whereby we will map the address with a mapping with a uint and a boolean value. Then we will have a array of the struct of the proposal struct basically. Then we will have the total supply, we will also have the balances, then we will have certain sort of events. Okay, let's write them down. I know it's gonna be a bit tough to remember each and everything that I just told. Okay, so public, we have members. Cool. Mapping, we will have for address, member public, member info. Cool. Mapping we will have for address. Again, I said for it's gonna be a mapping with uint, going with bool. Again, let's make it public, votes and proposal, public proposals. Cool. Now it's all about what do you call the total supply, right? Total supply will come as soon as the members are being joined. The more the members will join, the more will be the total supply, right? Total supply, and again a mapping that is basically for address with uint. I wanted to go public balance, right? We are done with it. So I'll just try to make it look a bit better. Control X, I'll go with it. Writing down each and every thing together, like all the mappings are together now. These arrays are together now. This event is like right. So we will have two events basically. Let me just write event proposal created, right, and we have a event vote when the vote will be casted, right? Cool. These are the two events that we will have, right? Let me just do events variables. Cool. Now all the work is left out for us is writing the code inside these functions. Let's first add the member, right? For adding a member, we will first require some sort of conditions. Let's say, is the member that we're gonna add already a member or not? Like, that is something we need to check out, right? So how we are gonna check it out? Okay, let's say she isn't a member, right? I'll just write the condition a bit later. So member info, I'll make some sort of changes. So how actually member info is going to work is, it is mapping from an address. So I'll provide the address over here, member, that we're taking from the user, and then we will have the member. Cool. So mapping is from an address, that is this member, from an address to the member struct, right? Same is the thing that we're doing here. Cool. So what are all the things? Member address is one such item that we are gonna do is that we will get from it. Member since is the value that we'll get from the block dot time stamp. Then we have token balance. Let's keep it a value of 100 for each and every member that's gonna come in, right? It's basically a hard-coded value for us. Members dot push, we have, let's say, membr member. Cool. We have this. Now balances, balances. I'll go with, for this member, to have equal to 100 value, right, and then a total supply. We need total supply will get an addition of 100, because as soon as the new member are joining, we'll have to provide it, right? Okay, now let's try the condition over here, because almost the same condition will be required when we are going to remove the member, right? So how are we going to do it? See, here we have added the information about this member, right? So what we need to do is, we need to check this member info. Inside that, I'll check for this particular address, right? So member info dot check this member address, right? Inside the member info, pass this member, and for this particular member, check this member address, right? Address. Cool. Is it equal to address 0 and comma already exists, right? Already exist. Cool. This is how we're gonna write it. So we are pretty much done with adding member, right? Let's simply go on with removing the member, right? There are some sort of items that we will require from here. Let me just copy this complete and just paste it down here, right? Didn't came that well. Cool. Okay, so to remove the member, first we need to check it out, does he or she even exist there or not, right? Only a small change into the logic will be, I'll have to just change it, and does not exist. I'll just say it does not exist, right? Simple. And other things would be, I'll keep it to address 0. Address 0. The value for this will go to 0. The value for this should also go for the 0, and at the end of it, right, members dot push, I'll have to pop it, right. For that I'll use for loop. Okay, now the balance for this particular member will go 0, and total supply will be reduced by 100. Cool. Now a for loop, uh, you all might be knowing how to write a for loop. You int I 0, I should be less than members dot length. Okay, and then I plus plus. Now if members dot, oh sorry, in members is an array, sorry, for equal to member, if there's a condition going through, then members, set it an I, let me just do it, members dot length minus 1, members dot pop. Cool. Then just a break. Cool, we're done with it. It's kind of simple code, just a basic logic, right? You can even create it if you have some sort of basic coding experience. You know how to write some sort of logics. Solidity isn't that tough language, I would say. Cool. Now let's create a proposal now. For creating a proposal, what actually we are having are these. First of all, is this, or just let this proposals, and this is struct over there, right? Cool. So I'll be just adding for proposals. I'll be pushing some value in it. What are those values gonna be? Those values are gonna be about the, what do you call that, struct, right? Struct. So into the array of the proposal, we need to push a struct of proposal, and what are all the values that this is gonna take is description first, and then underscore description. Cool. We're done with it. Then voting count. Let's put 0 in, because as soon as you're creating the proposal, you can't have some sort of value for it. Now executed or not, executed or not, no, it's not going to be executed because there are no votes for it. Done. Ending this, and ending this. There are 3 of them. So sorry, but I just messed up something or not. Push, we have this, emit. Yeah, cool. Proposal created. Why is this giving me error? It doesn't match. Why vote? Okay. So sorry. Vote count over there. Okay, there's nowhere else it's being used. Cool. Vote count is 0. I was writing it, emitting the proposal, right? Now, emitting the proposal, what all things I'm gonna emit are proposal dot length, right? Proposals dot length -1 basically, and underscore description. These are the 2 items that we are gonna emit. Now we are gonna add the same over to our events, right? First one was proposal ID, in text proposal ID. Then we have string of this here description. Cool. Let's for the vote for the casting the vote. Now, what we're gonna do is, whenever someone is gonna cast the vote, we are gonna index first of all who the actually the voter is, right? And on which proposal ID, and then you int how much token he has staked. Int. Cool, right? So now we are left out with two last functions. One is for the vote. So the vote, what you can think of is, we are going to require three conditions. Like, first of all, only the members are going to vote. Second one is the voter should have enough tokens. The one is they are just voting for the first time, right? Only one time they're gonna vote for it, right? So okay, let's say they surpassed all three. Let's first write the main items. msg.sender. Then we have the proposal ID. Okay. Proposal ID. I'm gonna make it go true. I'll just make it do this, and then I'll update the member info. I'll say the one with this address who is calling this particular function change their token balance, right? Token balance, change it to minus equal to underscore token amount proposal. In the add of the proposal, check out for the proposal ID. In that proposal ID, what you're gonna do is change the vote count to the number of token amount, right? Token amount with underscore, right? Okay, now simple, right? Now just emit the vote cast. For the voter we have .msg.sender. For the proposal ID we have underscore proposal ID. For the token amount we have underscore token amount. Cool, we are done with it. Everything is perfectly well. Okay, now let me just add this. I'll just copy this require line from over here, and I'll just paste it over there. Right. I don't want to type it again and again, each and everything, right? For the now, this time it will go with msg.sender. I'll remove it out. Member address is not equal to address 0, so like members can vote or does not exist. Let me just only existing member. Can vote. Cool. Another required statement can be so I told it should be checking out the tokens, right? Are they enough or not? So we will go with balances. We will have msg.sender. This person should have more than that, right? So token amount that they are providing from here not enough, otherwise it will just emit outright not enough tokens. Cool. KENS. Right. At the end we need to check if they already have voted or not. So how we are gonna do that is right, so if they have voted then it will be true. Right, so votes for the msg.sender. I'll have to check it. How I'll check it is I'll go to it from the proposal ID and I'll check it if it's false or not. Yeah, if it is false then just you already voted. Cool. Done. We are done with this now. When we are going to execute the proposal, but actually we are going to so now again we need to check for two conditions basically, like is it already executed or not, does this proposal have even got the majority votes or not, right? We're gonna do that, right? So first just I'm pasting the require statement. I need to make certain changes in it. Those are proposals. For the proposals, just check out the proposal ID. For a proposal ID, go to executed, check if it's false, right? If it's not, then already executed. Let's say it's it let's say it has cleared this condition. Now we're gonna again check it out for the word count, right? Proposals basically, so proposal ID, right? For this proposal ID, check for the vote count. It has so if it is more than what we had, the total supply divided by 2, right? If it does have that, then it's well and good. Otherwise, not enough votes. You can be just creative in writing those statements. Okay, let's say it has cleared all those. Now what we want is we want to execute, right? So we'll just change it to executed, right? So proposal ID, we will be writing it executed equal to true. So yeah, you are pretty done with whole of the smart contract. What you can further do is just copy it out and write it down in your remix IDE, run it, try it, play it with it, make some sort of changes, amendments, have fun with the smart contract. It's a very basic one, right? You can even want whatever you want to add it to it. You can just go and make some sort of readings around those ERC 4337 and everything, right? I'll be coming with more such kind of videos. So the motive behind these videos is just making you a structure of how smart contracts needed to be created, right? Because if you're watching this video, you might have some sort of basic knowledge about Solidity, right? That's what I'm taking into the consideration. Thank you, and yeah, I'll see you again in the new video.